Shake Table Lab by Ainsley-Hayden and Hayden Hotchkiss. First, we sketched a model of what we wanted our tower to look like so that we had a general idea of how to build it. Next, we combined 8 straws to make 4 long straws which served as the corners of the first story, second story, and the base. After that, we started to tape some straws together for the first and second stories, which we made smaller than the base for stability. Then, we started to add the crossbars for our first and second stories, which also helped stabilize the building. Finally, we finished the crossbars and attached construction paper to the first and second stories. Each story of our building was 18 centimeters tall, and the cardboard base was 25 centimeters all around. After we completed the construction of our tower, we placed 2 sandbags on each story, and our building did not collapse, bow, or bend, which was a good sign. To provide as much strength as possible for our tower, we agreed to add lots of tape to the base and crossbars of our structure. This will help our base stay sturdy and help the crossbars support the sandbags on the first and second stories. We also made our base wider so that the tower would not cave in. Our strongest parts were the crossbars because we doubled the straws and used a lot of tape. Another strong part was our first story because it was able to hold 8 sandbags and the construction paper never ripped. Our weakest parts were the corners of the base and the verticals. The corners of the base became detached from the cardboard and the verticals bowed outward. We did not use any string on our building because we used rubber to tie the sandbags down. The rubber was helpful because it was stretchy so that the sandbags were held down tightly, and we were able to wrap it around the stories twice. In order to completely secure our building, we used a lot of tape on our crossbars and on the bottom corners of our tower. On our first and second stories, we used some of the provided construction paper which acted as a platform for the sandbags.
Oh, 3, 2, 1, go.
Whoa, that's solid.
No, don't stable.
Oh no, the little flapper thing is flappering.
If you use enough tape, it's gonna be stable. One.
Yo, elbow shot.
They
Still
already
get
won.
extra points.
Well, they
No,
should
no,
survive
no,
it.
no,
Stay
in there.
Oh my god.
Oh!
No, they
My name is Ainsley-Hayden, and I built my building with Hayden Hotchkiss, and our building supported 10 sandbags and withstood 10 major earthquakes. And our strongest parts were our crossbars and our first story, and our weakest parts were the vertical lines that went all the way up and were on the corners of our tower. What I learned about building earthquake-proof structures is that you have to make the base wider and it should taper in as it goes up, and you have to make the base stronger than the rest of it, but it should all be strong. My building failed at the base because it bowed out, so it was like that and it bowed out, and then it made the whole structure come down. And what I could do next time to prevent that from happening is make the base stronger and maybe add 2 straws in the corners instead of just 1.
So our building, its weakest part, or where it failed throughout the Shake Table Lab, is that the sides where the building was supported, where the crossbars were connected, it was bowing out, and that was really bad because it was really weak, and once it started bowing and we started shaking it, the pressure got a lot greater than when it wasn't moving, and then it fell. And then if I was going to build my lab over, then I would probably change our crossbars and I would probably change the bowing out of our straws because I think that we could have made it better so that we could pull the crossbars in tighter so that the structure would be stronger, and I think that we could pull the crossbars in tighter so that the structure would be stronger, and I think that would really support the building a lot better so nothing would be bowing out or heading in, and then it probably would have lasted a little bit longer. And then I learned that you have to really double check your work because if you don't double check your work, you could be missing something. Like for us, we didn't really double check what we did on the building, and a straw was bowing out, and that really made a lot difference, like a big difference. So I think that if you double check your work, it can really make you can really make sure that you're doing everything correctly. And I really liked this project. I thought it was really fun overall. I liked how we got to add our own creativity with the tower. And even though like what we did on the building and a straw was bowing out, and that really made a lot difference, like a big difference. So I think that if you double check your work, it can really make you can really make sure that you're doing everything correctly. And I really liked this project. I thought it was really fun overall. I liked how we got to add our own creativity with the tower. And even though like it was a good idea to add triangles, we still got to add like how like what structure we want it to be, and we can add some extra designs and stuff. And that's really why I liked it the most. And I also liked it how we got to test our tower to failure, because if we didn't test it to failure, then it would just be kind of boring because everybody's practically past the first few steps. So that's why I liked the lab.
These are the results of our sensor readings. The blue lines are the z-axis, the orange are the y-axis, and the green are the x-axis.